Hello everybody, and thank you for joining me. Can you hear me at the back okay? Put up your hand. Yep, thank you so much. Lovely. So first, you are all extremely welcome to the talk, using OpenTelemetry, Splunk, and CI Jenkins to monitor financial software. My name is Robert Lynch. I am a Splunk developer, and I'm also a non-functional performance tester as well. That's my role. Now today I'm going to tell you a story, and the story started 2 years ago, and I'm going to outline the technologies that we used in this story that took about 2 years to deliver a solution that we are now selling or giving to our clients. Okay? So I'm going to introduce an overview of the technologies we're going to talk about today. So the first technology is Murex. That's the financial IT company I work for today. The offices are just over the road actually, and I think there's a lot of Murex employees here in the audience today. So you can raise your hands if you're here. Great, good to see the support. No pressure. Thank you for coming. So about 2 years ago, Murex had some questions, and the question was we wanted to monitor our very complicated financial IT software that gets installed in some of the biggest banks in the world, and we needed to monitor it better. So I'm going to briefly talk about these technologies and then jump into them deeper. So the solution that came from that question, how do we monitor our complicated financial software better? So what data do we use? What data framework? Is we decided to use OpenTelemetry. So we decided to push data out of Murex with the OpenTelemetry format. And once the data is out, the next question, well, data on its own is no good. You need to visualize the data. How are you going to visualize this? And there's many, many tools. You know, Datadog, Splunk, AppDynamics, Grafana, many, many tools. In our case, we were going to use Splunk. So Splunk is a big data tool. It takes in data and it visualizes data, as you can see on the dashboard. Now, one of the advantages with OpenTelemetry is you can push that into any of these tools because you're using OpenTelemetry, and I'll discuss that in a minute. But the next question is once we made these dashboards in Splunk to monitor the complicated financial IT software, and we're going to now want to deliver it to our clients or use it internally ourselves, the first question people ask is, how do you test this? How do you test that the output on these screens are going to be good? If you deliver this to a client with a version of the Murex binary, how do you know that this screen is not going to be blank or this screen here? You need to test your software. And this was a big challenge we had. And we went to the market and we could not find anything that was very good for us. So we decided we needed to build ourselves using CI and using specifically a Jenkins pipeline. And I'm going to talk about that as well. And then once we were happy that we can test the Murex, the Splunk app that's now taking OpenTelemetry data from the financial software Murex, we could now deliver it, and then the clients give us feedback, and then the loop continues. This took about approximately 2 years of software development. If anyone is in software, things don't happen overnight. Things take a long time to make a decision, and then you move on. So, the agenda for today. As I said, who is Murex, the architecture of OpenTelemetry, the Splunk dashboards, and then using CI Jenkins to test it in the end, okay? So 2 quick slides on who is Murex. Murex is a financial IT company. We're in business 35 years. We've won lots of accolades, and we're quite good at what we do. Now, the best way I describe us is, let's imagine you have a trader in New York City. He wants to buy 100 million Japanese yen off a trader in Singapore. He needs a software to price the trade. He needs a software to book the trade, and he needs a software to monitor that trade every day for the life of that trade. That's what we do. It's front to back office, okay? We have offices globally. I myself am from the Dublin office. I travel to Paris a lot. I travel to Beirut a lot as well, okay? That's a very quick introduction of financial software, and that's the company I work for. But we're here to talk about other technologies, OpenTelemetry. We had to ask ourselves a few questions. is the data at Murex good enough for the future? This is 2 years ago we asked these questions because we knew we needed to monitor our software that could sit on 10, 20, 30 big Unix machines better. And this was the challenge. And in order to monitor something, you need data. So we decided, we felt we needed to move to another data framework. So OTel was vendor agnostic. And what does that mean? Well, it means if you push out OTel data, any big data tool can generally take it in. So your Datadog, your App Dynamics, Dynatrace, they can all take it in. And more importantly, all the big guys are getting behind it, Google, Datadog, Splunk, they were all contributing to OpenTelemetry. So this seemed like the way the industry was going. So like any decision, you make a bet. You make a bet. Will we go down the OpenTelemetry road? The answer was yes. We're going to run a POC for 3 to 6 months, and we're going to see if it works for us. Now, another question. If we use OpenTelemetry, how do our Murex clients visualize the data? So I told you this at the start. So most visualizers accept OTel. So therefore, if the Murex application is in the bank and the data is coming out, they might have Splunk or Datadog, but they can connect to the data and they can then visualize it. How can we make it easy for our clients to view this new data? Well, in our case, we're going to develop an app. The app is in Splunk. And then we're going to give or sell the app to our clients. So if they have Splunk already and they have Murex, they simply download the app and it's plug and play. And it just works. Okay, so let's talk about a little bit of the architecture of the OTel solution. So again, now Murex, we're pushing data to OpenTelemetry. Okay, so how's it set up? So on the left side here, this is Murex. Murex can exist on X number of boxes, but in this case it's 8. And on the right side is a visualizer. In this case it's Splunk. So what we did was we created Python agents which sit inside each box. And the agents will send data, the Python agents will send data to a gateway down here, where it's consolidated, and then it's pushed out to a visualizer. In this case, it's Splunk, as I said. The gateway via HTTP sends data to Splunk, okay? So that's the overall view of it. And what we're doing in these agents, these are Python agents, we're interacting with the Murex code line, and we're pulling the data out of the code line. And I'll talk a little bit more about the push and the pull in a minute with OpenTelemetry. Initially we pulled, and now later on, because it's a success, we're going to push, okay? I'll explain that in a minute. So what type of data are we sending into Splunk? And generally when people talk data and observability, there's generally 3 types: logs, metrics, and distributed tracing. What we needed was the logs and the metrics. So in this case, we're talking about log data. Now, what does that look like? Well, log data could be known as unstructured data. Unstructured as in you have your stack trace here. So it looks like a log4j or something like that. And if you need to, say, take out session ID here, you might need to use regex or something like that. So as a big data developer, which I am, if I'm given this data and I'm told, hey, Robbie, we need this data, although it's OpenTelemetry and it's cool like that, I still need to write commands to parse this information. So the code is with me. I need to write this. But if it's OpenTelemetry, you get the attributes for free, and this is fantastic. And what that means is, hey, what machine did it come from? What source? OpenTel, what PID? You get the attributes. And I'm going to show a little video in a minute. The next one is metrics. Now, metrics I love because they're easier in my understanding to deal with and to work with, but they're a little bit more complicated to understand. Well, not really. So let's imagine the metric. I always use CPU data. Everyone understands CPU graphs. I think CPU graphs are shown in every demo I've ever been at because they're just understood. The CPU and the data point of the CPU is 0.01. That's the metric. And all these other things might be the attributes, okay? So the PID of the system, et cetera, the parent name, the environment. And if the metrics are sent via OpenTelemetry, the big data tool understands it straight away, and you see the benefit there. Now let's look at a quick video. So this is Splunk. It's a web-based tool. And we're looking at the first one, log type. And we can see here, this is just a general stack. Now, what's nice is, as I mentioned, you get the attributes for free. And I cannot tell you how important it is as a big data developer. So you have log, significant events, HTTP. And this is saying these attributes exist around this data point. This data point specifically is a log. But what's nice is I did no development here. This all came out of the box. Like Splunk or the other big data tools can probably pick these up very, very easily. And you can see the attributes. And then you can run extremely quick commands, stats count by log type. And you get a very simple table with simple numbers. I'm not saying it's amazing. But the point is, I did very little to get that. So the heavy lifting on the developer side, the Splunk developer, is practically zero. It just came out of the box, which is great. Now let's move to metric. So specifically in Splunk, they offered a nice analytic tool that our Python developers loved, because they were generating data and they wanted to see the data quickly. And once we plugged in Splunk, we could see data, for example, CPU utilization. This is all the CPU utilization we have. But again, the attributes come for free. And you're not, I mean, you design them, you send them. But let's imagine we're over X number of machines. And without doing much, I can see very, very quickly, I can put that in a graph and I can save that to a dashboard. And as a big data developer, because it's OpenTelemetry, this was really fast, really quick. I'm up and running like that. And not say a complicated graph, but I'm showing you, this is good. Now, Splunk have another command called mpreview, and why was this good? Well, our developers, didn't get a Teams message, I hope nothing bad comes up there. Our developers like to see the data they were generating. So they're generating the data, they're sending it to Splunk, and they want to see the data coming up here, okay? So very quickly, they can see all the data points and the attributes. So that they're making, say, a Java process, and they want to make sure it's coming through as Java. And they press go on the test, and it comes out. So that's a nice way to view the data for the developers, because you're in a development lifecycle. You're working with the developers, and they want to see results straight away. And they use Splunk to see the results, as opposed to Notepad++ and opening files. And the final way I'll show you, if you want to see, you don't build dashboards with those two. You build dashboards. And you want your dashboards to be super fast. It's less than 1 second. With something in Splunk called mstat. And in mstat, it's a way of bringing the data in very fast. You pick the metric you want, HTTP server requests. You do a big data pull. And then you decide which tables of the attributes or the metric you want to see. And then you save that to a dashboard. So all our dashboards were built with something called mstats. And this is Splunk specific. I'm sure all the other big data tools have their own commands, obviously, to pull out the metric data. That would be normal. So working with the OTel developers at Murex, let's have a little bit of a deeper dive. Now, they were Python developers, and we had a little chat. And I said, well, how did you find this? So this is a zoom in. If you remember, I showed you the architecture earlier. This is a zoom in on one of the probes we made. So for example, on the left is Murex, Java, C++, and we had a POC, a 3-month or a 6-month POC. Will OpenTelemetry work for Murex? It's like any POC. You have a timeline. You get 2 PIs. Can you get it to work? You assemble a team and you try. So instead of putting the OpenTelemetry inside the Murex code line, what they said was it's easier if we write Python probes outside the code line and we pull the data into the probes, okay? And then we send it to the OTel collector agent, which is the part you download from the community, and then this will consolidate to the gateway and send it on. Now, why did we pick Python for OTel? The community was very good at the time. So we had a Python developer, he would ask questions, he got back beautiful answers, and in general, he thought the community was good. And it was quick to do it for a POC. That's most important. We said we could get it done within 2 sprints, etc. Like, how do we get this out the door to prove the data is good? Now, are we using existing external probes for the future? Now, the answer is actually no. And the reason is, now that we've proven that it's good, that OpenTelemetry works and people are happy, we're going to write the probes inside the Murex code line now. Because now we don't have the fear that OpenTelemetry is bad, we think it's good, and we're saying, hey, let's push the data directly to the OTel collector agent. So we're going to deprecate some of these probes, and we're going to write it all in here. So it's not scalable for the future to have too many probes. For example, if you keep adding on processes, you're going to keep adding on probe, and the box can get overwhelmed, performance, etc., etc. So we thought it was easier to integrate them here. Okay. Was Splunk helpful in the process? They agreed it was. For example, the analytic workspace, the mpreview, these commands just helped them see their data. So they developed, and then they could see the data quickly. And you remember that you're on a timeline, you know, you have a few months to get it to work, like any software house. So they were happy with it in the end. Okay. Oh, is zero data. Now, so that's the OpenTelemetry part. So new data is now coming out of Murex. And what was the initial problem? The initial problem was we at Murex could be installed on X number of machines, and we didn't have a way, we did have a way, but we wanted a better way, that when a problem happened inside the bank, do you get an email alert from something? When someone wants to log in and say, hey, Murex has a problem, they need to go where? So why don't we build, and the whole point was, the Murex OpenTelemetry to Splunk, and now I'm going to talk about the Splunk part here, okay? This is what I'm on now. I'm going to talk about the development of dashboards now. So we've just talked about this part. So we developed 6 new dashboards. Now this is an APM, application performance monitoring, and the idea behind this is that, you know, it gives you an overview of the system, for example. It gives you process errors coming into the system, significant events, HTTP, infra monitoring, it's CPU, garbage collection. Is Murex, it's not all just CPU graphs. You know, it's kind of in-depth information about the Murex service, which has thousands of processes, consolidated to 6 dashboards. And the idea is that someone in the bank, if there's a problem at Murex, they open it up, and you see I put a red there, hey, there's a red there, there's a problem, I need to investigate. And they go on from there. So the idea is you make an APM off the OpenTelemetry data, okay? And now we use it internally, and we're going to push it out. We are pushing it out to our clients. Now let's have a look at the video. This is one screen. I show you this because anyone here might be of the situation where they're going to make OpenTelemetry. So this could be anyone. How quick is OpenTelemetry coming in, and how quick can you refresh your dashboards? Everyone wants real time. The problem is real time kind of doesn't exist when you get down to really complicated data. The best you can do is near real time. So let's kill a process here. Let's kill one process of Murex. So I'm monitoring all Murex here, and I kill the process. How quick does the OpenTelemetry get it? How quick does Splunk get it? Well, you can see that the spark line has gone dead very quick. These are 10-second pulses, because we're sending this data every 10 seconds. Every 10 seconds, we're sending the data. Then the Splunk dashboard has to say, hey, there's a problem. We're getting red here. This is dead. So the user looking at the screen goes, oh no, there's a problem with the authorized service. Now let's zoom in on the authorized. Now, in this case at Murex, Murex is a self-healing platform for authorized service. So authorized will respawn. Murex will go, hey, authorized is gone. Let's respawn. And it happens. But straight away, the OpenTelemetry picks it up. And in your dashboard, you put down starting. So you program your Splunk dashboard to realize over X number of pulses. If you get the first X, you put it to starting. The second one is dead. You see it's gone flat, and it's going to disappear now, over 80 seconds. You will not see it again. So if someone has logged on, they got an email alert, the OpenTelemetry data every 10 seconds, this window is only 80 seconds long. They can see business has returned to normal now. The pulse is alive, and we're moving on, okay? So this is just an example. This is not just specific to Murex. This could be you could be making your OpenTelemetry to send to any visualizer, and you want to know how quick can you get your data to pulse on the screen, because business will want real time. The problem with real time is it's very, very difficult. So you can get what we call near real time. So you have to decide how often you pulse your data, and the more you pulse, the higher your CPU on the back end goes. So you have to balance this, and then you hit problems. So let's talk about one of my favorite subjects, performance testing. Because when this came out, this just didn't work out of the box. Like everything in life, I wish it does, but it doesn't. We had performance problems. And I'm going to share with you some of the lessons we've learned with specifically performance problems. So initially, we were sending most of our data via log data because we kind of didn't know any better, to be blunt about it. We didn't really know that metrics were so much faster. So let's imagine, what does that look like? Well, let's imagine you have 50 errors and you send 50 stack traces. And then you want to tell the end user you have 50 errors. So the end user has to pull 50 stack traces and do a stats count errors equals 50. Now the problem with that is he's pulled 50 big log4j files. Now what happens if it's 500, 5,000, 500,000? Doing that type of data pull and wanting an answer in a 10-second refresh dashboard, it's not going to happen, basically, okay? So we did a test, and we had all our data in logs, and like I said, when the data's coming in is fine, and then we opened up, now this is a very six core VM machine, it was our little testing box, we wanted to keep the CPU very low. So the data coming in is fine, but then when we open up the dashboards, boom, CPU goes very high very quick. And we're like, oh no, we can't give this to the client, we can barely use it ourselves. What's the problem? And then we realize, okay, what we're doing is, as I described, we're taking in all the log data, and it's a big data pull, and then we're trying to do counts on these. We're trying to make metrics off events, which was a mistake. So then we had to go back to the developers and say, actually, instead of giving us, like, as well as giving us 50 logs, you need to give us a metric. And that metric says that we have 50 errors. One little line, metric 50, simple. So reading a metric 50 is like that, nothing to it, simple. You also get the stack traces if you want. Of course you get the stack traces because developers need stack traces. You need to debug the problem. I'm not saying you hide the problem. I'm saying you need both. And when we converted some dashboards, we saw straight away, like an initial load, it goes up, and then it's much lower in this particular use case. And we're pulling the same amount of data, 141,000 events, 100,000 events, approximately. This is below 1 second. This is 4 seconds. The difference is massive. Okay? So if you're designing dashboards with OpenTelemetry, my advice is use as much metric data as you can. If you learn anything from today, metric data is so much faster, okay, than using the event data. Now, let me explain that with a video. All our dashboards load with metric data because the end user wants to see something quick. Now, this is a mock data. We have hundreds of thousands of errors here. Our system does not throw these errors out. Of course, I simulated these errors. And let's inspect here. So we see below 1 second, and you can see, you know, it opened quick enough. But you have the data on demand. I want to see the raw logs. So you send two types of data. One is the metric, and now this is a simulated stack trace. It's just a big long lump of X's, okay? But if I inspect that, you can see it's 4 seconds, and that's what I mean. Now that's not so bad. I'm only going back 10 minutes. What happens if you want to go back 1 hour? You're going to see straight away the difference. The difference is quite big. So you go back 1 hour, and the metric data, it loads a little bit slower because obviously you're going, but not too much slower. But you can see, because you're pulling now 100,000 events, and they're just raw events, it's obviously taking longer. Now, if you wanted to do a stats count on that, it's just going to take longer, and your end users will get frustrated because it took long. So I'm not saying logs are bad, logs are needed, but I would advise you to load up your dashboards with metric data and have logs on demand. That's the lesson that we learned, okay? So we were very happy with that. Now, testing. So continuous integration. Excuse me. So this is, I've talked about Murex, I've talked about OpenTelemetry, I've talked about the Splunk app that we've created, and it has 6 dashboards that we're giving to our clients. But as I said, if we want to give software to a client, and if you expect them to pay, and if you deliver software and one of these screens is blank, they're not going to be happy. And how do you test a GUI where many, many things can be changing, okay? And we looked into a few technologies, and we really couldn't find one on the market that would help us with the dynamically changing dashboards and the dynamically changing data. So the data can change, the code line of the Splunk app can change, and also the Splunk version can change. So how do you test all these three components in one test? So we managed to do it using Jenkins pipeline. Okay, oh sorry, that's not supposed to be there. Right. So the new monitoring solution produced new problems, new challenges to test. We made the decision at Murex that we're going to inject the Splunk app, which is basically HTML, into the Murex code line. So this is it here. We're underneath the monitoring thing, observability. And if you're doing that, you then obviously need a way to test. So we needed a way to make sure we can test all critical parts. So as I mentioned, there's three critical parts. One is the app itself. So let's imagine a developer adds in a new panel, or they remove a panel. Is it good or is it bad? Is it a mistake or is it not a mistake? Before you deliver to the client, you need a test that's automated to test this. You cannot just simply deliver to a client. The next is the OTel data itself. Remember, the data is coming out of Murex. What happens if a developer changes a metric from A.B.C to C.B.A and doesn't tell you? Your dashboard is expecting A.B.C. So your dashboard now will be blank. You're not getting anything. And again, you cannot deliver this to a client, okay? And then of course, every software, Splunk, every software has versions. So a bank will ask us, hey, are you okay on version 9, 9.1, etc. So you need a way to quickly test all components. So what's the solution? Well, we went down of using CI, continuous integration with Jenkins, okay? Now, can I get a show of hands of how many people use CI in the room? Continuous integration? Awesome. Great. Well done, everyone. And how many people are using Jenkins pipelines inside this? Okay. That's a good showing. Yeah, that's very interesting. I always like this because when we make a software choice, I always like to know that we're in line with the market. You know, so obviously people are using the same. If you're the only person using it, then maybe you've made a wrong software choice. So what is CI? CI is kind of continuous integration, that's what it means. And it's basically a way of testing all the changes you do quickly. So there's no point having a developer work for 3 months and then doing a massive merge maybe and breaking everything. What we like to do was create a CI using a Jenkins pipeline that can test each of these components separately. So the idea is that if we're changing the dashboard, the Splunk app dashboard, they can trigger a test that will run and then get a green at the end saying, yes, that was a good output. The outputs of the Splunk dashboard have not changed versus the reference data you've given me. And I'm going to show you a deep dive now of what I mean by that. But the idea here is that we can now load the Splunk app from any Murex version. We can now also load in the data from any Murex version with a data generator we created. And now we can load in any Splunk version to test it. And we test all three components inside a Jenkins pipeline that we run it at midnight every night, or a developer can run it on demand for testing, okay? So this is how we test all three components, okay? Now, what are we testing? Because I've talked about testing on components, but what are we actually testing? Well, the output of any of these Splunk dashboards, you can output them to CSV files, quite simply. And they don't look very sexy. They look like this. They're just like big lines of data that go all the way down, and it's just data, 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 data. But let's imagine at the very start of your test, you output every single dashboard, and you make a master, a golden master. And then if you run any test after that, you change the build, you change the data, you change the Splunk version, you check it off this. So you have hundreds of CSV files from each panel. Each panel you output a CSV file. And we do this with Python, and we use curl to ping the Splunk server and pull back the CSV file. And then we save that as the answer. So that's how we have designed this test. Because as I said, we didn't in the industry find a way. We had things like Selenium and things like this. And we just thought that if the dashboards changed, it'd be too much of a headache to change the test. So we decided that this was the way forward for us, okay? And we've only developed this recently enough, in fact. So what's the workflow of building a Jenkins pipeline? How does it work when you try to bring it all together and bring the developers on board? So let's imagine, as I discussed, the three components. Let's imagine you have a sandbox. A sandbox is just a VM. You just get a VM and you load in your Splunk version 8, 9. You load in the Murex app that you're going to deliver a client, for example, and the data generator that's reading from the code line, so you know your metrics are in line with the data is correct. And you send all this into Splunk, because Splunk has to receive the data. And technically, you could log in here and view the dashboards I showed you, except you don't. You get the Python scripts to interact with Splunk via curl and to produce all these CSV files, bang, in one shot. So we produce hundreds of CSV files. And when you're happy with these, this is step one. You then say, okay, this is my golden master. This is the very first time you run the test. Nothing should change. I'm going to upload these to the CI as a reference. Now let's imagine I'm going to run it on version X+1, okay? And the binary changes, for example. Something changes in the app, or you want to do Splunk version 9 because you want to validate it. You want to see, is all the outputs the same? And you take down a new version of Splunk and you run the Python tests and you already have the reference files stored and the output files should equal 100%. Nothing should change, okay? Now, the question would be is, what about time? Well, if your data generator is doing what it should be doing and you're testing right now, you strip out time. So time becomes not an issue here, okay? You just want the raw data itself, not time. That itself has its own challenges, and I'm not going to get into too much detail on that, but that's that. Now, what does a pass look like? Well, very simple. The reference files equals the new data, and the CI passes, and we move on. Oh, sorry. Oh. Now, what happens if a fail comes along? You have a fail in the system. It's like, oh no, like the CI failed last night. We run it at midnight every night. We need to make sure that everything is going okay. We run a test on binary X+1, and you know it's in the CI. We took down the new binary, the Splunk app, and what happened is the infra monitoring failed SPL 13. So not only when you're, and the reason I'm saying this is when you're designing a test that's complicated, you need to be able to debug it quickly. It's very important. Having a test that just says fail with no verbose debug is disastrous. You're going to spend your life debugging it. And then your bosses are going to wonder, like, what, this test was supposed to be brilliant, but you can't debug it quickly. It takes you 2 days to find the problem. That's no good. So you need to be able to identify, like, what dashboard and exactly what panel failed very quickly. So let's just take, what does a fail look like? Well, very simply, you were expecting, say, dead, and you got an OK, just as an example. And it's a fail, okay? So the reference file did not equal the new populated SPL. That's as simple as that. It's a fail. It doesn't look sexy, but that's as simple as that. Now, the issue could be the Splunk version. You might have loaded in a new Splunk version. The data might have caused the issue, or the Splunk dashboards, which is inside the app here, okay? So the three components, either component could have caused the fail. So now you need to debug. Now, in this particular case, let's just say a developer got a defect. And when I open up the infra monitoring, he got a defect and he or she said, I have column 1, 2, and for example, this is a new example here, I need to add a column 3. Okay, so it could be CPU, I/O, and I/O weight or something. But he or she just added it to the Splunk dashboard. Okay? They didn't update the reference data, which is here, which is say it will fail, okay? They just added it into the Splunk dashboard here. And when you ran it Of course, an extra column is going to be produced of data. And of course, an extra column will come out here or here. And of course, the test will fail. So then you need to go back and you need to talk to the developer. Okay, so, and then of course, you have to get an email highlighting the issue. That's just standard when you're testing. Now, what happens? How do you fix the fail? So you have to make a decision. How am I going to fix the fail? So you deploy a CI. Often we deploy a CI into a sandbox for debugging. Now there's many ways you can do this, but it depends. And one of the reasons we like to do this is because if we do this, we can then fully access the Splunk GUI outside the Kubernetes cluster. So when we run our CIs normally every night, it's running inside a Kubernetes cluster and test, test, test. And then you have a fail. You can redeploy in the Kubernetes and debug there if you wish, but sometimes we deploy the whole thing to a VM. And then we access the Splunk GUI. And then we open up the infra dashboard and we see, column 3 is red. You accept or reject the change. You now have to debug and make a decision, okay? So the decision is, after you you contact the Splunk developers and you say, hey, did you do this on purpose or what was the reason? And they might say yes or no. You have to make a decision. The metrics developers, so maybe someone by accident put in x.y.z instead of y.x and they go, oh, that was a mistake. I snagged it doing something else. The data has changed, therefore the dashboards are now changed. Or maybe the problems with Splunk itself. Maybe the new version of Splunk, version 10, which will be out soon, maybe there's a bug in Splunk and all the dashboards are now empty. And you have to go back to Splunk himself and say, hey, are you aware that when I run this basic command, it doesn't work? Maybe they're not. Maybe it's a problem with Splunk. You know, easily. Now, in this particular case, as I said, the reference data was wrong. We talk to the Splunk developer, and we say, actually, we need to just update the reference data. Okay? So you can see we just go, no, do you know what? We actually want that to be green. The new data in the sandbox is correct, and now we need to update that back to the reference because we wanted the extra panel in the Splunk dashboard. We wanted to display this, and we want it to go into here. Okay? Okay. When you rerun, you should get a pass, and green is good, red is bad. Basically, it's simple like that. Now, I'm coming to the end of the presentation. So, what's next? So, as I said, this took about nearly 2 years to complete. We started out with the financial IT software. We needed a way to monitor Murex better because we had a way, but it wasn't good enough. So we embraced what we thought was a good new technology, OpenTelemetry, about 2 years ago. And we started pushing the data out. Although some in the Python developers, some wasn't at general availability, we still went ahead because the community was so good. It was helping us on the way. Now, our Python developers were very happy with that, and they managed to create some good data. Then, of course, I come in and I make the Splunk dashboards because that's what I do. I'm a Splunk developer and a performance developer. And then we said, well, actually, these are really good. And our internal QA started using them, and they were happy. I said, well, actually, we can probably now give these to our clients. But before we do that, we need a proper test. And in this case, we said we need to test it every night. And we use continuous integration if we can test every night. And the way we did that was, let's try to do that with Jenkins. Well, a Jenkins pipeline specifically is what we picked. And now we're starting to deliver to our clients. They seem happy. And they're giving us feedback. And of course, version 2.0 is on the way, et cetera, like any normal software license. What's the future for OTel at Murex? What does it mean for our clients? Well, the good news is its plug-and-play solution are now available for our clients. So our clients can now take down the Splunk app and get it working. Or the Murex code line will push out the OpenTelemetry because we can't assume everyone has Splunk. Of course they don't. They might have Datadog, Grafana, Prometheus, etc. Well, not Prometheus, sorry. But we can't make that assumption. So the vendor agnostic way of OpenTelemetry worked, that if other big banks Dynatrace, they could say, yeah, let's take it in. And they're going to build their own apps. So some of our clients are building their own apps, that's fine. And some clients are saying, yes, we have Splunk, we'll take it in and we're off, okay? So our clients need to make their own decision on this, okay? We can only open the door and they make a decision. We had to make a decision that we're going to try with the Splunk app. In the future, we might make other apps, maybe. We have to see what the market holds. Murex developers, due to the success of the project, teams are now creating more OpenTelemetry. So I showed you 6 dashboards, but other teams are coming along saying, hey, I need to monitor my service, because we've lots of services at Murex, lots of different teams. I hear this OpenTelemetry is good. Would you recommend it? And we say yes. And how can I do it? And who can help me make the Splunk dashboards? And I say, well, me and my team will help you make the Splunk dashboards, et cetera, et cetera. So it's kind of like a technology that's kind of growing inside Murex now, okay? So the conclusion, very simple conclusion. OpenTelemetry is a success at Murex. We're generally happy. We've made a choice 2 years ago, and I'm happy to say so far so good. I was at a talk earlier where they were promoting OpenTelemetry as well, which always makes me feel good because, as I said, taking any new technology is a gamble. You have to explain to your boss 2 years later. No, I'm not the one who made this final decision. Lots of people made this decision. But you know, you don't want to pick a wrong technology. So far we're happy that we picked what we think is a good technology. This might be wrong in 5 years, who knows? But let's hope it isn't. A big thanks for all the people in the team that worked in the project. Okay, so thank you very much, and I hope you enjoyed that presentation. Excellent. I think we've 3 minutes for questions, if there is any questions. The man has a question there. How you doing? Shout out there, it's okay. Well, the main decision process was, I suppose, when we talked to people, there was lots of people involved. It was new and upcoming, correct? It was vendor agnostic, but most importantly, Google, like Datadog, all the big technology vendors, they were all giving time. Now, sorry to repeat for the, because we're on TV. Okay. All the big software houses of the world seem to be going behind it. They seem to be giving time. And like Datadog, Splunk were saying, hey, we are promoting this. They would put their hands up and say, we are promoting this. We are spending time in the community helping this. And this was a big push towards us. So I think this was one of the big things that helped us say, you know, because it's a gamble. You know, you could make the wrong gamble. So this was one of the big things that, it wasn't us, it was all the big, it seemed to us that all the big visualizers were also going down that road. And that's why we went that way. Okay, thanks for the question. Hello. Is a mic coming here?
Did you have the problem with the number of gigabytes generated by all those logs and metrics and decisions to, let's say, keep them for 1 day or 1 week or 1 month?
Well, yes, we did. So it is a good question. Thank you. So let's go back. So the question is, did we have a problem with the logs and how long do we keep it? It might be too back. The size of the files. So when you're sending the data from Murex, what happens, for example, through the gateway, if the gateway goes down, for example. Let's imagine the gateway goes down. How long can you keep all this data before it sends again? Do you know what I mean? So let's imagine the component drops, but you're still generating data. What we decided to make a 1 hour retention policy, because the data gets very big very fast. Because you're not sending this data to disk. This data is going over the wire. And if no one is there to receive it, the memory inside Murex is just going to get bigger, 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 bigger very quickly. So you have to make a decision. And our decision was we will only keep 1 hour until the gateway is restored, and then the data pushes through. Now, of course, you can change that, but then you have to have like your disks on file and your things ready to receive it. So we already had data, so we say, at Murex. But of course, we were very conscious of how big things got. And you have to monitor the size of, because financial software has to be fast. We do a lot of performance testing at Murex. So yes, we were very conscious of the size of everything. And you must always monitor this, okay? And especially if the service drops. Hello.
In Splunk, you go to see what happens 3 months ago.
Yeah.
You won't have the details, only the aggregate.
No, because if the data has still gone through, as Chris, if the data has gone to Splunk, Splunk has its own retention policy. And in Splunk, like any big data tool, you decide, I want to keep for X, Y, or Z. Okay? So once it reaches Splunk, it's Splunk's problem to keep it. And you can keep it for X, Y, or Z. You know, as a Splunk administrator, I have to make this decision. Okay? I think we're out of time. Okay, thank you very much for listening, guys. I appreciate it.